Hello and welcome to RPGeNet version 2.0. RPGeNet is a web application tool created to help users find new potential driver genes of retinal dystrophies and help better visualize the complex interaction network of the retina. For more information on how RPGeNet was created, please see the introduction to the tutorial page or see our article linked on the About page. This video is a guided tutorial that will help show you how to find your gene of interest in the network, learn how to edit, expand, or contract a graph in the Network Explorer, learn to set and change the expression visualized, learn to find the shortest path between two genes of interest, and finally learn to find all the pathways between your genes of interest to driver genes or to the skeleton. Starting with the RPGeNet homepage, we see three options available to us. The first being Network Explorer, followed by the shortest paths between genes, and finally pathway to level. We will start with Network Explorer. To begin, we have to type in our gene of interest. I will be typing in circle, which is the example. But we can actually put in more than one gene if we wanted to, like let's say make out 3. Now for the sake of this tutorial, I will keep this simple and only have one gene. Our next option is the interaction level. So here we basically have 5 options. The first is the skeleton graph, which is the core of the RPGeNet network. The skeleton subnetwork is only made up of the shortest paths between driver genes of retinal dystrophies. The level 1 subnetwork is an expansion from the skeleton core by the addition of parent and children interactors of the genes found in the skeleton. Level 2 is the next expansion, adding the parents and children of the genes added in level 1. Logically, level 3 is the expansion of parents and children of the genes added in level 2. In the case of RPGeNet, the interaction graph saturates at level 3, which means that there are no more parent or child genes that can be added in. However, there are still genes remaining that don't connect with the interaction graph because they don't have experimentally validated interactions. These genes are added into the whole graph. For more information on these unconnected genes, you can look them up on the Unconnected Genes section of the data page. So for this tutorial, we will click on skeleton because it is the smallest graph and because it has a bias towards genes related to the retina and retinal dystrophies. Our next option is the gene distance. The gene's distance option allows you to add parents and children of the interactors of the genes inserted. Now this might sound similar to the interaction level, but the difference is that the interaction level gives the scope for where RPGeNet can look for genes, and the distance asks if you only want the direct interactors of the gene inserted, or if you would also like to include the parents and children of the interactors of the genes you inserted. If you would like to see the parents and the children of the interactors, then you have to bump this up to 2. However, do remember that interactors may have multiple genes, a ridiculous number of genes for some, that it interacts with. So it is not recommended to increase the distance if the user does not have a powerful enough computer to handle it. It would be better to add the parents and the children of the interactors manually within the Network Explorer, and for this reason, we will keep the gene distance to 1. Finally, we have the expression. This option will color the center of each node based on the expression value of the gene, depending on which of the 4 options you pick. The absolute option colors based on the raw expression of the gene in the retina. The ret-al option is based on the differential expression calculated comparing expression in the retina with all 32 tissue samples in the experiment, including retina itself. The ret-other option compares expression in the retina with all the other tissue samples without the retina. Finally, we have the ret-liver, which compares expression in retina with the liver. And why the liver? Simply because it is a randomly chosen tissue sample that is unconnected to either the retina or the nervous system. For more information on the microarray experiment used, please look at the expression section of the data page where you can see some of our figures of the differential expression and also the geo ID for the experiment. For this tutorial, we will click on Absolute, and we will then click on Explore Network. So here we are inside the Network Explorer. You can see our gene of interest circle and all its interactors within the skeleton. Do remember this is only the skeleton, which means that these genes are inside the pathways between driver genes, and between the shortest paths between driver genes. So there could technically be other interactors that interact with circle that are not included here because they are not inside the skeleton, because they're not within the shortest paths between the driver genes. Yeah. So if you look at your right side, you have basically the control panel. And we'll start here with the show properties. This is the default option, and basically this default option allows you to click on a node, and it gives you a whole bunch of information on the gene. So in this case, we pick circle. It tells you that it's a driver gene. On the other names, it gives you aliases as well as the ensemble, gene IDs. It also gives you a quick summary that is provided by RefSec on the gene if you want to know a little bit more about it. Then it gives you a little bit more data on the gene. For example, the type, if it's non-syndromic, syndromic, or if it's both. In this case, it's non-syndromic. It will tell you a little bit about the level it's in. So because it's a driver gene, of course, it's in the skeleton. It also tells you the number of variants, which is 33 in this case. There is the expression data, which is the expression values for circle and all the different options that we've given. We also have the gene ontology codes for each gene, and finally they have some external links to important websites like GeneCards, UniProt, OMIM, retina. Okay, so here we can close. But it's not only for nodes, it also is for the actual interaction itself. So we click here on the interaction between circle and VHL. You are given the interaction, which is a physical interaction, which means it's between two proteins. It gives you the direction, gives a little bit of the summary, again, the level, whether the VHL and circle has genetic interactions, physical interactions, or whether it's a PPX interaction, which is basically unknown. We can't really tell whether it's genetic or physical. But in this case, there are basically 6 sources that tells us that VHL interacts with circle, and they are physical interactions. So it's protein to protein. It also gives you some sources here, which is the BioGrid from PubMed, and as well as from String. Again, these are PubMed IDs that they give for evidences in String. Yeah. Then here we move on to the node addition button. So what this does, it's going to add the parent and children of the node that you click on. So we're going to click on MECAL3, which has 2 interactors apart from the circle, and we're going to click on PPM1A. Awesome. Got all these interactors. And real quick, we're going to move down here to connect genes. So what this does, it's going to connect all your genes, not just from the interactor, from the gene eventures to the interactor, or from the interactors and the parents and child that we added, but also between each and every one of them. Yeah. So we connect, and you can see all the added relationships, or all interactions. We're going to go back up here and to node deletion. Here we can delete a node. So let's just say we wanted to delete PPM1A. And you'll actually notice that we have a couple of genes that now don't link up to anything. And so here we can remove those unconnected by clicking on remove unconnected. Ta-da! Yeah. Then we can mess around with the layout, and we have multiple options like the dagger, which is the option that you see now, the color option. You also have the circle option, whichever option suits your needs. Here, this is the border size. This basically just changes the size of the borders on the nodes. Not much, but some people like this. Then we have the node size, here we can disable the node size so that all the nodes are the exact same size, and the size is based off of the number of variants. So I mean, if you don't want to see Mikhail has more variants than NeuroD1, well, that's perfectly fine. You can just disable it. Finally, we have these control. So here, if we scroll in, let's say, we can click here on fit, and it returns to an expanded, zoomed out view with all the genes there. If we click on image, this basically saves a PNG if you want to. We have this export button, which gives you a table with all the interactions within this particular graph. And then we have the save button, which will basically save a JSON file that you can then upload here. And so this JSON file will have all the exact same thing that you had when you saved it, which means the position, all the interactors, everything you deleted, everything you added, it will be there. Yeah, basically here with the upload, but we're gonna close. And then we have the legend here, which will show you the color codes, which the border is based on the level it is in, the shapes for the driver genes, also the colors of the interactions, whether it's physical, genetic, unknown, the size of the interactions, which tells you how many evidences there are for it, also the number of variants, which is the size, again, of the node, and then at the end, it gives you the expression and basically the gradient for that, for the absolute, and also for the differentially expressed options. Right. We can close that. Here at the bottom, we have a search genes option. So here, let's put in circle. You can put in many genes that you want. I'm going to put my gene, which is obviously not an existing gene. And let's say NeuroD1. You will click search. And here on the side, you will see these options here. The green means that it does exist within this, with what is being visualized. If it's red, it either doesn't exist at all, as in this case, or it's just not within this visualization. You will also see within the graph, if you look at circle, it's highlighted in green. But in case you can't see because there's too many genes or whatever, you can click on the gene that you want to search, and it will have a close-up, which you can then expand out. Yeah. Finally, you have the section where you have an undo, redo button. The level that tells you if you're at the skeleton, level 1, level 2, level 3, whole graph, etc. You also have the expression, which you can change here live, whether you want the absolute raw within the retina, or whether you want one of the differentially expressed options like ret versus all. You can see the colors have changed, and they will change slightly depending on which one you choose. And then here, you have the map that you can use to move around. This one's another fit button, and up and down, a zoom in, zoom out, and again, to move in, move out. All just options that you can use. Okay, we are going to return to the home page, which you can do so by clicking on the RPGeNet logo. And now we're going to look at the shortest paths between genes. And here for the source gene, we're going to type in circle, and we're going to click in row. Okay, the expression is the exact same thing as above. We'll keep with absolute. And here, click in shortest paths. So for this case, there's only one shortest path between circle and row, which has a heat shock protein in between them. So here we can click on Explore Network, and basically will be shown into the Network Explorer, which we can then do node addition and add, the parents and children in a circle. We wanted to play around with it just like we showed you before. Yeah. I'm going to go back to the RPGeNet homepage and then go to the pathway to level. Let's type in PMM2 as the example. So here we get the path 2. So we can choose whether we want basically a pathway that goes between the gene of interest to the driver genes, the skeleton, and you could also do, if you wanted to level 1, level 2, level 3, or the whole graph. So, whatever you wanted. We're going to go to the driver genes. And again, the expression is in the above 3 options. Same thing. We'll continue with the absolute. Click here on Get Path to Level. And we wait a little bit. So, unlike the shortest paths option, for the PMM2, we got many options to go between the gene and driver genes. Again, it'll give you the path. And here we can click on Explore Network again, and we'll go into the Network Explorer view, of which we can, again, mess around with this graph, add things, delete things, whatever we want to do. All available to us. And that is it for this tutorial. I hope this made it easier for you to understand how RPGeNet works. Hopefully you'll be using this. And thank you again.